Pleasure to be here. Unlocking value from our Quicksilver Nickel Cobalt project. I want to start with driving into the Quicksilver project is located near Lake Grace and is leveraged to four primary drivers of value: the district, the deposit, mining and metallurgy. The project is positioned in proximity to grid power, sealed roads, railway with access to multiple ports across Western Australia. Our resource is significant at 26.3 million tonne at 0.64% nickel and 0.04% cobalt. Recently, it's also been confirmed the addition of rare earth elements and scandium mineralisation within its footprint. The metallurgical test work to date has demonstrated a potential pathway to production for the resource. The pathway is mechanical, low energy, and only requires degrees of screening, scrubbing, regrind and magnetic separation to generate multiple saleable products. We do not need harsh chemical processes. The deposit can generate three primary products. These are a nickel cobalt concentrate, an iron chromium magnetite concentrate, and industrial aggregates. Additionally, the rare earth elements and scandium test work has been incorporated into the planned forward works and looking at the best way to extricate value. The district: roads, rail, ports and power. The project is surrounded by infrastructure and accessible by a network of sealed roads. The town of Lake Grace is serviced by rail via a spur line that runs from Hyden to Agen, and that then feeds both the Kwinana port and the Albany port. We have four ports with approximately 300 kilometres of Quicksilver, and that's all networked by sealed roads to the project. And we have grid power up to the farm gate. This will enable us to leverage logistical options to lower transportation and shipping costs. It will also insulate the project from supply chain disruptions, either natural or otherwise. Back one. Let's jump to an extra slide. Missing one. Let's jump to slide. But anyway, what has become apparent is that Quicksilver is not just a resource of nickel and cobalt, but it's a unique clutch of critical minerals. It's a basket of metal goods, if you will. The ore body is clay-hosted, and its secondary nickel, cobalt, scandium mineralisation that we believe has been overprinted with rare earth elements. While nickel, cobalt, scandium deposits are rare, there are a few significant resources in Australia. The overprinting of rare earths, however, is extremely rare to the point that we have not been able to find any reported occurrence of this globally. We certainly appear to be unique. There is still further opportunity within our current resource. The ore body is open along strike, and currently there has been no drilling at depth. The confirmation of rare earth elements and scandium within the resource envelope has been an exciting development for us. Our rare earth element trio highlights include 4 metres at 3,295 ppm, and that includes 1 metre at almost 8,000 ppm, and 10 metres at 2,548 ppm, and 1 metre at almost 4,000 ppm. It should be noted that we have only sampled approximately 5% of our current pulps, and only 6 complete holes have been a part of the confirmation for rare earth elements. There's a lot more to go. The highlight of scandium has been 32 metres at 124 ppm, and this includes 20 metres at 154. This intercept only starts at 3 metres deep from surface. We are also able to fast-track assaying test work as we can utilise the repository of current samples, and this means no new drilling required. The 15th of March was a big day for us and a big step forward for the company. A review of our historical data uncovered significant, high-grade intersections, and importantly, the mineralisation is near surface, widespread, and contained within the same footprint as the nickel cobalt resource. We do not need to mine additional tonnes to dig up the scandium, and for the other matter, the rare earth elements as well. You can see from our best intercept over 100 ppm, and in addition to the 32 metres at 124 ppm, there are 22 metres at 115 ppm, including 7 metres at 190, and 44 metres at 77 ppm, including 6 metres at 114. On the right, you can see the distribution of scandium to the extent of the mineralisation in general gram metres. This is near surface, widespread, extensive and open. The high gram metre lines across the southern edge indicates the potential for further resources in this area. This deposit requires no drilling and blasting and is effectively free dig for the load and haul fleet. This significantly reduces the operating costs as it eliminates one of the major cost centres of mining. The flow-on from not requiring drill and blast is that the supporting mine infrastructure can be minimised, workshops can be fit for purpose to the load and haul fleet, and obviously no explosives means no surface magazines. Having multiple saleable products allows us to value engineer an array of mining scenarios targeting grade and stockpiling strategies. Various economic scenarios can be interrogated across the saleable products and input costs. The inherent schedule flexibility allows us to determine the best value scenario for this point in time. The geometry and shallow nature of this deposit will enable mining to quickly pivot between high-value schedules when there are material changes in economic circumstance. This provides the ability to keep optimising the mine and realising value when we're in operations. The geometry and shallow nature of the ore body will also result in the mine having a relatively low stripping ratio. This is a downward driving force on operating costs as there are less waste tonnes moved per total ore tonne. Less waste tonnes also means smaller waste dumps, and this has a positive outcome when looking at mine closure and rehabilitation costs. The mining itself of this deposit has effectively the best of all worlds. It's low capex, low opex, has minimal infrastructure requirements, and the ability to keep operating with schedule flexibility to keep driving the highest value proposition through varying economic circumstances. Unlocking the minerals. The Stage 2 metallurgy test work demonstrated a potential pathway to production and the potential to develop a mechanical, low-energy, customised, multi-product beneficiation flowsheet that generates 3 primary products. We can reject the silica-rich component of the material feed by screening and grading the oversize to form high-quality industrial aggregates. The saprolite in the ore contains a magnetic mineral of the iron-chromium spinel group. The test work indicates this can be liberated into a concentrated iron, nickel, chromium product through moderate regrind and magnetic separation. A concentrated nickel product can be formed via scrubbing as the metal is concentrated in the natural slimes fraction. There is further potential to upgrade this product with the rejection of quartz, goethite and volatiles via a pelleting process. While the market for aggregates is local, the nickel cobalt and iron nickel chromium products are a simple transport to port and direct ship to smelter in Southeast Asia and China. We do have a fourth product, though we don't consider it part of the primary stream. Vermiculite is also present and has been confirmed by sampling the mica in the gravity tails. The grades we're getting around there is around the 2% nickel range. This is, and I'll repeat, this is only a small portion of our total product generation though. The test work for rare earth elements and scandium already includes the forward works to advance the understanding of their potential. This could possibly add further product streams or potentially byproducts as we further develop the processing flow sheet. I'm sure we've heard a lot about it, and obviously decarbonisation is one of the biggest structural changes to the global economy in the 21st century. Electrification of the automotive and other industries, as well as the transition to renewable sources and storage, are exponentially growing. But we're still also very much technology driven, with smart technologies and real-time analytics. Smart technologies are also critical to the management and operation of these green industries. Most people would be familiar with the uses of nickel cobalt, and I don't intend to rehash that here. However, generally a bit less so with rare earth elements. It's important to highlight that rare earth elements are still the critical ingredient for the magnets that make the best performing, lightweight electrical motors. Scandium, on the other hand, is fascinating. Scandium is used to form superalloys and is very much used by the aerospace and aeronautical industries. However, what's not so obvious and currently emerging is the potential for superalloys to the electrical vehicle market. There are basically 2 levers you can pull to improve the performance of electrical vehicles, with range being the constraint. You can improve the batteries or reduce the weight. The use of alloy frames and panels are already widespread on EVs, and it makes a logical step to move in the industry towards superalloys as production increases in scandium. Research is also currently underway to generate solid-state lithium batteries. Now, what's really interesting here is they are looking into using scandium to improve the performance, and obviously solid-state batteries reduce fire risk in the EV market. Scandium is also used in fuel cells by improving the conductivity of the cathode, and also it can prolong the life of the cell because it can be used as a coating for that cathode as well, and reducing degradation. Additionally, scandium also has a high affinity for hydrogen, which means it can absorb and release hydrogen gas more efficiently than many other materials, which makes this a very desirable superalloy to be used for the storage and transportation of hydrogen gas. With our project of nickel, cobalt, rare earth elements and scandium, we are not just exposed to part of the electrification, renewable and technological industries, but uniquely positioned in all of them. I'll take a step back to when we released the resource. So in 2018, in October, the resource was released to the market. Met test work subsequently followed through multiple stages. The uniqueness of this deposit has created some early hurdles, and I can appreciate this has been a somewhat frustrating time as this process has been worked through. However, the uniqueness of this deposit now presents the opportunities, especially with the results from the Stage 2 MET test work. This has progressed the development of a mechanical low-energy flow sheet for the deposit. I think we'll actually end up looking back at our Stage 2 MET test work and look at that as a transformational point for the company in unlocking and advancing the Quicksilver project. Retesting samples from previous drilling for rare earth elements and interrogating the resource database for scandium has borne fruit. This will lead to further potential for value adds, which is incorporated into the plan forward. We are currently diamond drilling to collect bulk samples required for the Stage 3 MET test work, and this program will be finished in early April. Once we've completed our analysis of the Stage 3 MET test work, our plan is then to move into a formal scoping study. But I'll stress, it's imperative that the test work is done before we move to scoping study, because the test work drives the scope drives the schedule. Our goal is to discover and develop value-accretive projects with a three-pronged approach to our assets. Firstly, our primary focus is to progress the technical understanding of Quicksilver through the Stage 3 MET test work and progress to formal studies. Secondly, we will prudently utilise resources for targeted exploration on our 100% owned assets and targeting nickel, copper, gold and base metals. Thirdly, we will utilise JVs for the advancement of projects through our JV partners, giving us exposure without expense. We will also continue to review and assess external assets with a particular focus on re-engineering opportunities. Now, the single hardest thing to do in this industry is to discover a new deposit. But it's certainly been my experience that there are a lot of projects out there where the engineering is, want of a better term, suboptimal. And they're quite often very high value propositions that sit within those projects with a shift in view on how to tackle them. Our approach will be systematic, staged, fiscally prudent, as we progress these strategies to ensure we get the best value for the money invested. We not only have a team of significant experience, but more importantly, a history of success. Jordan is a highly respected geologist who has been instrumental in discoveries across Western Australia, Queensland, Canada and Africa. Grant, our non-exec chairman, is a seasoned mining executive who has considerable experience and has a particular highlight being the Sylvania Platinum in South Africa, which took an innovative approach to realising value from waste dumps and harvesting platinum group metals. And we've heard my background obviously in the introduction. We have the experience, the success and the critical skills to unlock Quicksilver while remaining leveraged to exploration success. With a market cap of under 4 million, Golden Mile Resources is a great opportunity considering the potential value from Quicksilver and portfolio of exploration opportunities. We aim to provide critical minerals for a cleaner future and plan to achieve this through our cornerstone Quicksilver project. The Quicksilver project is 100% owned, is a significant resource of 26 million tonne of 0.64% nickel and 0.04% cobalt. The project's located near Lake Grace, and I think we should be all aware that WA is one of the single best mining jurisdictions globally. And we are positioned with excellent infrastructure, including grid power, sealed network road system, and rail to key ports. The deposit is leveraged to low capex and opex, and due to it being free dig, has great schedule flexibility with an upside to value engineering. We are progressing to develop a custom, mechanical, low energy flow sheet to deliver multiple saleable products. The confirmation of rare earths and scandium mineralisation provides the potential for further value enhancement. We are in an excellent position to take advantage of the structural market changes from the global decarbonisation through the electric vehicles and electrification of other industries, renewable energy generation and storage, and ongoing technical development. We are not just exposed to part of these, but uniquely positioned to all of them. And very lastly, for everyone's benefit to read at their leisure, the disclaimer, and thank you very much.